Hey guys, and welcome back to this class, Deep Learning Part 5, Recurrent Neural Networks in Python. In this lecture, we are going to review some important deep learning concepts that we are going to make use of in this course. If you've taken parts 1, 2, 3, and 4 of the deep learning series and learned about hidden Markov models, you should have more than enough experience to tackle this course. First, let's talk about the softmax function. The softmax function is what we use to classify two or more classes. It's a little more complicated to work with than the sigmoid in particular. Its derivative is harder to derive, but we'll let Theano and TensorFlow take care of that stuff for us. Remember that all we do here is take an array of numbers, exponentiate them, divide by the sum, and that allows us to interpret the output of the softmax as a probability. Next, let's talk about backpropagation. All machine learning models have two main functions, prediction and training. Going in the forward direction is how we do prediction. At the output, we get a probability that tells us what the most likely answer is. For training, we use what we've always used throughout these courses, gradient descent. That means we take the cost function, which is usually the squared error for regression or cross entropy for classification, calculate its derivative with respect to each parameter, and move the parameters slowly in that direction. Eventually, we'll hit a local minimum, and the slope will be 0, so the weights won't change anymore. In Deep Learning Part 4, you learned about how we can use neural networks for unsupervised learning. Unsupervised learning is interesting because it allows us to find patterns in the data when we don't have labels. This is exactly what we want to do when we're doing language modeling. We have a bunch of text, but usually the text doesn't have a label. It's just a string of words that form some kind of pattern. One view of unsupervised learning is that we're learning some kind of probability distribution that the data follows. Next, let's talk about Markov models. You may have had some exposure to these if you took my course on hidden Markov models, but if not, that's fine too. They are very simple. One bonus for taking the HMM course was that you got a first look at the Theano scan function, and this is going to be used extensively in this course. Markov models work like this. Suppose you have a bunch of states. These can represent words in a sentence, the weather, or what page of a website you're on. A Markov model is a model that makes the Markov assumption. That's just when the probability of transition to the next state depends only on what the current state is. So for example, if you want to know whether or not it will rain tomorrow, that's only going to depend on today's weather. You can see that this is quite an unrealistic assumption. For example, consider the sentence, I love dogs and cats. Let's say we're trying to predict the last word. We know it's cats. But all we're given is the word and. And if I say the previous word in a sentence is and, what's the next word? You of course will have no idea because and by itself lacks context. In this course, you'll see that our models no longer make the Markov assumption.